Welcome to the next video. In this video, I want to show you what the requirements file is and what a Makefile is. So I have created here for our Python package a requirements.txt file and a requirements.dev.txt file. As you already saw before, I have created also a requirements file for our whole course folder or for the GitHub repository for the whole course content. And the requirements.txt file is a quite handy way to tell pip which packages should be installed to run the local code here. For example, if you are a user and you see our vector library on GitHub and you just clone the library or you fork the repository, for example, then you can define here in the requirements file which packages every user should have installed to be able to run our code or to use our code. So if you want to use our library later on, to use the vector2d class, for example, we could define here all packages that are always needed to at least use our package. Furthermore, if you want to work on our package, so if you want to just extend our package, or if you want to remove bugs, for example, etc., you would need more than these two runtime requirements packages. And here I have defined another requirements dev file where I've listed all the packages that you would need if you are a developer of the package. So the users of the package just need, for example, as I stated before as an example, NumPy and SciPy. If you want to work on this package, so if you are a developer of this package, you might need all the testing packages, the linting packages, and the packages to generate the documentation. The standard user that is just using our package don't need these packages. So it's a common way to separate, at least here, these two requirements files to separate the standard user from the developer of the package. And here, as a side note, all packages that are listed here in the requirements file should also be listed inside our setup.py file here in the install requires list. Every package that I list here in the install requires list will be also installed if a user will install our package with pip from PyPI. So all the values or all the global variables here that are defined in setup.py are exported to PyPI. So if a user later on will install our package with pip install fast vector, for example, pip will check under the hood if in your current Python environment NumPy and SciPy is installed. If not, pip will install NumPy and SciPy since I have listed them here in install requires. These requirements files here are just for people who will clone, fork, or download the code from GitHub. So these requirement files won't be used on PyPI. So that's the main difference. And as I said before, if we have the requirement that NumPy and SciPy should be installed, I have listed them here for the PyPI users, and I have listed them here for people that just download our code from GitHub, for example. And all other packages that are just needed if you are a developer of the code base are listed here, for example, in the requirements dev file. You could call them requirements developer also, so it's not a really naming convention here for these files. You just have to run the correct command in the terminal, which would be pip install -r and then the file name. So for example, requirements dev.txt, and then pip would go over this file here line by line and would check if the packages are already installed. As a further side note, you can define in the requirement files also here in this list which versions are needed. So for example, if we need NumPy in at least a version 1.18, you could define here greater equal 1.18, and then pip would check if NumPy is installed, and if NumPy is installed, is the installed version okay, so is the version above 1.18 or equal to 1.18. The same can be defined here in the requirement file. So the syntax is exactly the same here. So if you want to define that NumPy should be at least 1.18, you could define it like this. If a version has to be lower than something, you can just define here less equal, for example, 1.20 and so on. So these comparison operators, work as you expect them to work. So there's not really much magic there. Okay, that's about these requirement files. And furthermore, I have created here a Makefile file. And if you do not know Makefile or Make is a tool that will use Makefiles. And inside a Makefile, you can define a target name, or let's call it an alias name for certain command line arguments. So if you have a lot of command line arguments and you are just too lazy to type them all on your own, you can just here define once a command. So for example, if you want to run PyTest, for example, on our tests directory here, I just could run here make test, and then this command would be executed under the hood. So under the hood here, I would see Python-m pytest test is executed. And I just called here make test to call this command under the hood. So with a Makefile, you can just define your own, let's say, command line arguments that are an alias for some other command line arguments. So you have just to define it once here. This will be handy in the next video, where I will show you the test coverage and test coverage HTML, which are a bit more complex command line commands. So as you can see here, we called several tools here with our Python version, so PyTest and CodeCov and so on. And with a Makefile file and these alias targets here, you can just state them once, and you do not have to remember what the command was. So you just define it once here, and then you can call make and the alias name here. So that's a pretty handy way to just be lazy. It's not very much used in the Python community. So Makefile comes from the C++ community, but nevertheless, in my opinion, it's a very nice way of ease the use of all the command line arguments that you could define in your package. So for the moment here, we would just have 3 commands, but you can define many more commands that are, for example, much more complex. Okay, so that's enough for the moment. We will see us in the next video again. Bye bye.